Welcome to Online Solutions. We are on a mission to give you the best. Remember to subscribe. Thanks.
Allow me today to take you through quantitative aspect of electrolysis. So Michael Faraday did a very intensive study of electrolysis, and they came up with a law that states, so we want to state Faraday's law. That states that the mass of a substance, produced during electrolysis is directly proportional to the quantity of electricity passed. So Michael Faraday, after doing an intensive study on electrolysis, he came up with this law that stated that the mass of a substance produced during electrolysis is directly proportional to the quantity of electricity passed through that. So it means that the quantity of electricity that is passed through a substance that is being electrolyzed will produce the mass that is exactly equal to the amount of the quantity of electricity that is passed through. So the mass that is going to be produced will depend on the quantity of electricity that is passed through that system which is being electrolyzed. So that's what it means. So it is directly proportional. So then quantity Q is quantity Q, which is the quantity of electricity, is calculated by current times time. The current we use capital I, and time we use T. So I times T is equal to quantity of electricity that is passed. So quantity, let us look at the SI unit. The SI unit of quantity is quantity of electricity. Remember, the SI unit of quantity of electricity is the coulomb. Capital C. So we use the coulomb as the SI unit of quantity of electricity. Remember the formula that quantity is equal to current times time. This time must be in seconds. the time must be in seconds. At times you are given time in minutes, time in hours, so you must convert that time to seconds. For example, if 0.4 amperes, which is now current, the current is A, the SI unit of current is A, flows for 10 minutes, then the quantity Q of electricity passed is Q equal to current times time, and the current is 0.4 times time, which is 10, because 10 is in minutes times 60 to convert to seconds, and this one will give you 240 coulombs, because this is quantity of electricity, and the quantity of electricity is in coulombs. The SI unit must be in coulombs. So let us look at Faraday constant. Faraday constant. Faraday constant. Michael Faraday found out that this man here, Michael Faraday, after doing a lot of analysis and experiments, he found out that 96,500 coulombs are required to produce 1 mole of a monovalent metal. That 96,500 coulombs were required to produce 1 mole of a monovalent metal from its ions. Very correct. To produce 1 mole, that this amount was required to produce 1 mole of a monovalent from its ions. Therefore, the quantity, this now number here, 96,500, was called Michael Faraday's constant. So this number is Faraday's constant. We call it Faraday constant. So it means that 96,500 coulombs is equal to 1 mole of a monovalent. So a monovalent contains, remember, monovalent is a metal like silver, which has valence 1. This is 1 electron, so that we call it has 1 electron. Therefore, it means 96,500 coulombs is equal to 1 mole of electron. 1 mole of electron. 1 mole of electron. Of an electron of a monovalent metal. So it means that this one is equal to 1 Faraday. This, remember, this one is Faraday's constant. Therefore, it means that 1 Faraday equal to 96,500 coulombs. And what is 1 Faraday? 1 Faraday is the number of the charge of that metal. If it is a monovalent, then it is 1 Faraday. If it has the charge of 2, like magnesium, zinc, it will have 2 Faradays. if it is aluminium, it will have 3 Faradays. So we will ask that if 1 Faraday, this is for a monovalent, suppose it was a divalent, what will be the quantity of 1 mole? So I hope you have understood that. So we will look at an example and then you will be able to understand. For divalent metals, for divalent metals like magnesium, which is charged as a positive charge of 2, or copper, this one you can see it is 2 positive, therefore the charge is 2, positive 2. It means that it will require 96,500 coulombs times 2, meaning that we know if 1 Faraday is equal to 96,500 coulombs, and this is for monovalent. What about it is a divalent? That is now 2F equal to what? Therefore, for a divalent, we will have 2 times 96,500, and that one is 193,000 coulombs. 193 coulombs for a divalent, right? So it means that 1 mole of a divalent metal, 1 mole of a divalent metal contains 193,000 coulombs. Very important. For if it is a trivalent, such as aluminium, which is 3 positive, it means that it will contain 96,500 coulombs times 3. Very important to note. Let us look at this example here. Calculate the mass of silver that is formed when a current of 0.4 amperes is passed through a solution of silver nitrate for 15 minutes. So you have been given that the RAM, relative atomic mass of silver, is 108. So first, we know how to calculate quantity of heat. We know that Q, quantity of electricity, not heat, quantity of electricity, equal to current times time. Current is 0.4 and the time is 15 minutes. So 15 minutes times 60 to convert the minutes to seconds. This one will give us that is 6 times 15 times so it is giving us 360 coulombs. But we know silver is a monovalent, therefore 1 Faraday equal to 96,500 coulombs. 1 Faraday. But remember, 1 Faraday equal to 96,500 coulombs equal to 1 mole. And 1 mole of any element is equal to RAM. For this case, is equal to 108 grams. So the question is that calculate the mass. So we will say if 1 Faraday, and which is 96,500 coulombs contains this mass, we will ask 360 coulombs will contain what mass? 360 times 108 divided by 96,500, and this one will give us 0.4 grams. So this is the amount of that is the mass that will be produced. Example 2, calculate Calculate the mass of copper that is formed when a current of 0.7 amperes is passed through a solution of copper 2 ion, copper 2 sulfate for 25 minutes. The RAM of copper is 64. So in our solution, we know copper, it is a divariant. That is the first thing you must remember and put it in your mind. So 1 mole will contain 2 Faradays because of 2 electrochemistry-Faraday, the divariant, that it has 2 electrons. So will contain 2 Faraday, and we know that 1 Faraday equal to 96,500 coulombs. We will ask 2 will contain what? Therefore, it is 2 times 96. So 1 mole of copper 2 ions will contain 193,000 coulombs. Very important for you to note. Very important. So let us calculate the quantity first. Let us calculate the quantity of electricity in this. Quantity is equal I times T, and the current we were given is 0.7. Time was 25 minutes, so you multiply 60 to convert it to seconds. This one will give you us 1050 coulombs. So we want to know the mass that this quantity of electricity will produce. But there is one thing we know for sure, is that 1 mole of copper 2 ions, which is equal to RAM 64 grams, it will contain 193,000 coulombs. That's what we know for sure. Now we will ask 1050 coulombs will give us what mass? So it is 1050 times 64 divided by 193, and this one is going to give us 0.35 grams. I hope you are enjoying the lesson. Question 3. How much time in minutes will be required to form 0.504 grams aluminium metal when a current of 1.2 amperes is passed through a solution of aluminium nitrate? RAM of aluminium is 27. So that is the question. We want time. In our solution, first remember we are dealing with aluminium, which is the valence 3. Therefore, it has 3 electrons in the outermost energy level. We know that. It means that 1 Faraday contains 96,500, and 1 Faraday is like 1 electron coulombs. So we will ask 3 Faraday, 3 electrons will contain what quantity of electricity? Therefore, 3 times 96,500 coulombs will give us 289,500 coulombs. You must put that in mind before you continue. So let us see. We don't have time, but we know this is what aluminium has got. But we know 1 mole of aluminium is equal to 3 Faraday, which is equal to 289,500 coulombs, which is equal to RAM. So let me put it in 1 mole of aluminium equal to 289,500 coulombs, which is equal to RAM, and the RM of aluminium we have been given is 27 grams. Yes. So we want to ask if the mass that was produced we have been given the mass that 0.504 grams were produced or were deposited. So we can ask if this one contains this 0.0, is it 0.0? Yeah, 0.504 grams will contain how much? So it is 0.504 times 28,9,500 divided by 27. 54.04 coulombs. So it is giving us 54.04 coulombs. But now this is the quantity of heat, electricity, quantity of electricity. So what we know, Q equal to IT. We don't have time, but we know the current was 1.2. So 1.2 times time will give us the quantity of it, which is 54.04. So we will divide by 1.2. We will have 43.03 seconds. But we want time in minutes, so 45 45.03 divided by 62 will give us 75 minutes, and that is the time. Electrolysis of an aqueous of a salt of metal M resulted in the deposition of 1.07 grams of a metal upon passage of a current of 1.32 amperes for 75 minutes. RAM of metal capital of M is 52 and 1 Faraday is equal to these coulombs. Calculate the charge of the metal ion. We want to calculate the charge of the metal. Now quantity equal to IT. We have I, we have time. So we have current. The current is 1.32 times time, which is 75, times 60. This one gives us 59.40 coulombs. So this, we know the amount, the mass that this quantity of electricity produced. The amount was 1.07 grams was produced by 59.40 coulombs. So we would want to know the amount of the quantity of electricity for 52, which is the RAM, for 1 mole grams. What will it produce? So this one, it is 52 times 59.40 divided by 1.07, and it's going to give us 28.8673 coulombs. Yes. 1 Fahrenheit equal to 96,500 coulombs. So we will ask 28.8673 coulombs will contain how many Fahrenheit? So that is 28.8673 times 1 divided by 96,500. Divided by 96,500, and this one is going to give us 2.99, which is equal to 3. So the charge of the metal is positive 3. The charge is positive. The charge is positive 3 because they're asking for the charge.